Hello dear students. Last video we talked about different drugs which can affect of the synthesis of a bacterial cell wall. For example, cephalosporin or beta-lactam. Those drugs which can affect the transpeptidation steps. And because of those bacterial cell wall is not synthesized. Of course, we talk about autolysin inhibitor, with how penicillins can affect the autolysin, and we talk about bactericidal and bacteriostatic drugs. Now we are going to detail about the different group of penicillin and mechanism of resistance and some important pharmacokinetics. As we explained before, penicillin it have two types: wide spectrum penicillin and narrow spectrum penicillin, and each of them is divided by two parts. It's natural penicillin, and wide spectrum it can be divided by extended spectrum. So in narrow spectrum penicillin there is natural penicillin. Natural penicillin, the example of natural penicillin, it's it's penicillin V and penicillin G. This is, let's suppose, in the family of penicillin, this is mother, this is what? Papa, like father. So in mother it's penicillin G, and father is what? Is penicillin V. So why I made this penicillin is big? Because they are heavy and they cannot enter to the bacteria poren, and it won't affect on what? On gram negative. But they can reach to where? To penicillin binding protein, which present in gram positive bacteria, in gram negative bacteria, and in gram negative bacteria, in gram. So they are these drugs, they are resistant to beta-lactam. Which type of these drugs you know? So for example is nefacillin, methacillin, cloxacillin, decloxacillin and oxacillin. This type of drugs, it won't necessary to give with what? With sulbactam or clavulanic acid or azabactam. All of these drugs, they are very strong. So in the family of penicillin, we have wide spectrum. Wide spectrum, it can be divided by two parts. Extended spectrum. An example of extended spectrum, it's what? It's amoxicillin and ampicillin. They are smart penicillin. These two drugs, they are smart penicillin. So they are susceptible for penicillinases and not able to pass in what? In which type of bacteria? In pseudomonal bacteria, which is gram negative bacteria. But other drugs, what they are called, we called supermodel smart penicillin. They are very smart. They can cross via the poren of the many gram negative bacteria, and even in pseudomonas, or we can say this drug is called anti-pseudomonal penicillin. For example of the drugs, it's what? It's carbapenicillin, ticarcillin, piperacillin, acetylocillin, and methicillin. They are very smart. They have special body gun for protecting themselves. So these drugs we will give with what? With sulbactam or azabactam or clavulanic acid. They need body protector. They need sulbactam, but these drugs they don't need because they are very strong. We call this weak daughter in the family. So weak daughter in family, it's need for protection, for security. So we should give some sulbactam, azabactam or clavulanic acid to protect themselves from what? From penicillinosis. So here in this case, like we have consecutive concept of resistance against penicillin. There is two types of resistance. There is natural resistance and acquired resistance. Acquired resistance, it's when bacteria affect of the when the bacteria have affection on the antibiotic and it's become acquired resistant. But natural resistance, it's some bacteria they are naturally resistant to what? To antibiotic, to beta-lactam antibiotic. For example, of those bacteria like all fungi, all virus, or also we can say the human cells they are what? They are natural resistance to beta-lactam, to antibiotics. So I want to ask you one question. Are you killing human cells by what? By penicillin? No, because human cells does not have peptidoglycan. So inside the human cells, so for example, if we say this human cells, in human cells there is no peptidoglycan, so that penicillin will come and will bind to the peptidoglycan and will start acting on the cell. That's why penicillin it won't work on human cells. Mycobacteria, like for example Mycobacteria leprae or Mycobacteria tuberculosis, also they don't have peptidoglycan. That's why penicillin does not work on them. So now I will explain those cells without peptidoglycan. If cells have peptidoglycan, penicillin can work on that cell. But if cells will not have peptidoglycan, so penicillin cannot work. For example, mycoplasm. Mycoplasm, it won't have cell wall at all. So there is not the place for acting of penicillin. Mycobacteria. Mycobacteria, as I explained, they are very thick layer, and the layer of the mycobacteria is what? Is mucolic acid. So they don't have peptidoglycan. That's why penicillin it won't work on mycobacteria. Chlamydia, fungi, human cell. As I say also, human cell does not have peptidoglycan. That's why penicillin cannot work on human cell. But in some bacteria, in some case, some bacteria have peptidoglycan, but they are naturally resistant, like Pseudomonas to penicillin G and penicillin V. Acquired resistance. How bacteria make a resistance to antibiotic. Some bacteria start producing enzyme, for example, like to kill beta-lactam ring, to destroy the beta-lactam ring. For in some ways, for example, in the first way, bacteria can produce beta-lactam production, or we can say beta-lactamase. For example, if we take this bacteria, the bacteria, inside the bacteria we have chromosome. In chromosome also there is the genes. But in some bacteria there is extra chromosome, chromosomal DNA. So in some bacteria there is one chromosome which producing gene, and gene will suppress and producing what? Penicillinases, or we can say beta-lactamases. But in some bacteria there is extra chromosome. For example here. So in bacteria have a great screen against the protection of antibiotic. Bacteria keep proliferation via the through what? Through conjugation. Plasmid may go to other bacteria. So what's bacteria? So in some bacteria can proliferate, can multiply through what? Through conjugation. What's conjugation? Bacterial conjugation. It's called bacterial sexual activity. So we can call this bacteria sexy. So here, if you take one part of the bacteria, here it's what? It's a chromosome. Here also another chromosome. And when the genes of the chromosome is suppresses and start producing what? Producing protein. This protein starts pushing the layer of the bacteria out. So this layer, it will push out and it will go to another bacteria which neighbors bacteria. So the protein here which secreting, it will go and transfer to another bacteria. Then so when protein here will go to another, this bacteria and this bacteria, both of them, they will become resistant to antibiotic. So in this way we can say when one bacteria is resistant to antibiotics, there is fastly or there is very fast another bacteria which around himself will become resistant to antibiotic. So when we give penicillin to the bacteria, one bacteria it's producing protein and the protein will transfer to another bacteria. Then another bacteria also become resistant to penicillin. So in this way it's dangerous. Because why it's dangerous? Because one bacteria can pass plasmid to many other bacteria around himself. So resistance will spread rapidly, and other bacteria also become resistant to beta-lactam. It's the first acquire resistance of the bacteria. Second, some type of bacteria, they can tight the pore, like they make pore tightly. So penicillin, when it will come, it won't cross the pore and have a resistance to penicillin. So for example, in MRSA, in methicillin-resistant Staphylococcus aureus, you give all penicillin but cannot work because of the genes bacteria mutant. So when in some cases in MRSA, in methicillin-resistant Staphylococcus aureus, the bacteria produce special enzyme which can make can make the protein, binding protein, bigger, and when penicillin it will come, it won't have effect on the bacteria. So we say this is dangerous staphylococcus, call it MRSA. So alteration of the penicillin, it's an alteration of penicillin binding protein. That's why on this staphylococcus, what we will give, we have another choice of the drug, so that have affection of the bacteria. It's called vancomycin. Vancomycin, it will go and not allow newly secreted NAM and NAC. So I explained it in previous video on how NAM and NAC will secrete. It will come to outside of the cells of the bacteria. So vancomycin, it will go and will not allow new secretion of NAM and NAC to bind with extensive cell wall component, and cell wall it will die. In third way, alteration of the penicillin binding protein. It's to be resistant in Staphylococcus pneumonia. So the most effective drugs in Staphylococcus pneumonia, what? It's penicillin G. So many enterococci altering PBP and become resistance to antibiotic. In short explanation, acquire resistance, how it will become. So what's the mechanism and what's the acquirement resistance? It's in 4 points. First, destroy the beta lactam before reaching the bacteria. When bacteria will produce penicillinases, so penicillinases will go outside the bacteria and it will destroy penicillin. For example, this is bacteria. Bacteria will produce penicillin and it will penicillinases will go out. Before reaching the penicillin to the bacteria, penicillin will die. Second, tightening of the pore. For example, here we have pore around the bacteria. So when pore it will tight, so penicillin cannot go inside the cell. In this case also penicillin will not affect. The third one, penicillin come and pulling out. In some cases when penicillin is coming inside the cell but it's pulling out by the bacteria. In some other cases, for example, here we have penicillin binding protein, but penicillin binding protein it's become altered. Like alteration is happen with penicillin binding protein, they become bigger molecule, and when penicillin it will come, penicillin cannot bind to penicillin binding protein and it won't have effect on the bacteria. In this case we will give what? We will give vancomycin. So now we have a very short explanation about what? About pharmacokinetic of the penicillin. Some penicillin can be given orally or some penicillin can be given parenterally. Some other penicillin we can give in both ways. Those penicillin which can given orally, it's penicillin V, amoxicillin plus clavulanic acid, or indonyl carbonicillin. So penicillin V, why we can give orally? Because it's acidic stable. Usually for oral infection we can use this penicillin V. Those penicillin which we can give parenterally, it's what? It's carbamazepine, piperacillin, ticaracillin, and ampicillin plus sulbactam. So ampicillin and sulbactam it's only available in IV or IM. Or in some cases we can give both orally or parenterally. So in some penicillin also, it can be available in what? In depot form. Depot form, what's depot form? When depot form, it's when you are injecting penicillin with another uh, uh, drug or with another combination. It will go inside the muscles and it will stay for a very long time inside the muscle and will release the penicillin gradually. So depot form uh, depot form, it can be given one injection and work for what? For long time. It's long acting penicillin. We can call long acting penicillin. For example, procaine penicillin or benzene penicillin. These two drugs, it's depot form. So when you give, for example, when you give procaine penicillin IM, penicillin stick to procaine. So penicillin, it will stick to this procaine, or it can be stick to benzene, and its combination from penicillin is releasing from the procaine or from benzene very gradually for very long time. For example, uh, benzene, it can release penicillin for up to 4 weeks. So if you give benzene penicillin IM, so this benzene, it can be released penicillin for duration of 1 month, like gradually it will release penicillin, if maybe uh, every time, but very in the small amount. So we will give 1 IM one day. For example, today we will give 1 IM. This benzene penicillin, it will hold the penicillin and each time will release small amount of penicillin. So that's why we can use this penicillin in what? In children which we can susceptible with rheumatic fever. So every month we give one deep injection of benzene penicillin, and it's which type of penicillin in family. So as I talk about in previous picture, I talk about family of penicillin. So there is narrow spectrum, there is wide spectrum. In this case, which type of penicillin you will give with benzene penicillin or with procaine? It's what? It's penicillin G. So we give penicillin G with procaine for acute rheumatic fever. So penicillin G, it have availability to combine with procaine or to combine with benzene, and will release for very long time. Now I'm going to talk about absorption of penicillin in GIT. So how penicillin will absorb in GIT? For example, we have two types of penicillin which can be absorbable in GIT. It's what? It's amoxicillin and ampicillin. No, sorry, ampicillin, it's also absorbable, but very little. But amoxicillin, it have good availability to absorb in GIT. So the amoxicillin is better absorbed in GIT. If we draw GIT here, this is amoxicillin. So amoxicillin, it can come to GIT and it can absorb, go to blood circulation, and then go to the place when there is infection, for example, go to ear, go to mouth or other place of the body which have infection and start working there. So now we can say, is it good or bad when amoxicillin can absorb in GIT very well? In one way it's good and in another way it's bad. Let me explain why in one way it's good. It's good when patients have oral infection or throat or ear infection. Amoxicillin it can go through GIT and find the bacteria and kill it. But in another way it's bad. Why it's bad? If you have for example, if you have bacteria in GIT, for example, bacteria like Salmonella or Shigella, when you give amoxicillin and it does not stay in GIT and absorb too, it will absorb very fastly into blood circulation and it won't kill Salmonella and Shigella. So in this case, which type of the drug we give? In this case, we give ampicillin because ampicillin it won't have good absorption in GIT. Ampicillin it will stay in GIT and will start killing Salmonella or Shigella. In another thing which I want to tell you, penicillin cannot cross blood-brain barrier. So I want to tell you what's blood-brain barrier. It's for example, and from where blood-brain barrier come from. If we draw here, and we can say this is blood vessels, this endothelial cells and capillary. So from where blood-brain barrier it came from? So there was a doctor when he was injected cuts with special colors called I1 blue. Then he killed the cat and he looked the cat. Which part of the cat it's become blue? It's changed the color. He saw that only all body of the cat become blue except brain. So it's mean there is some way which call it blood-brain barrier when there is some molecule cannot cross blood to brain fluid. So ampicillin and in some cases when ampicillin normally cannot cross blood-brain barrier, but in some cases when ampicillin is coming, in some cases when there is infection in the brain, we can say like if there is encephalitis or meningitis, when there is infection of the brain, endothelial cells here, these endothelial cells cannot attach to each other strongly. So when penicillin it can come, it can destroy this connection and it can go to central nervous system. Yeah, I draw it for you here. This is endothelial cell. Endothelial cells, they are tied into each other here. So when penicillin is coming in normal way, they are tightening very strongly normally. If there is no infection, when penicillin is coming, it cannot cross here and go to central nervous system. But in some case of infection, for example encephalitis or meningitis, this binding it's broke and penicillin can come and can enter to central nervous system. Also, penicillin cannot enter the deep part of the bone, but when there is a different disease of the bone, for example osteomyelitis, penicillin can pass and can enter to the bone. Also penicillin can cross placenta very effectively, and penicillin not have any teratogenic action. When penicillin is crossing placenta, it won't have any teratogenic action. So most of penicillin can go out through where? Through kidney. In some cases, when penicillin will go out in the kidney in proximal part of the hyaline loop, some penicillin will reabsorb here, like 10% of penicillin it will reabsorb and will go back to blood circulation. Also penicillin can be taken from the milk of the mother. Can be go when mother is using penicillin, penicillin can secrete from the milk and go to the newborn. Also penicillin can secrete through saliva. That's all about the pharmacokinetic and family penicillin. Thank you very much.